This is your video for practice quiz number 14. It says find the volume of the cylinder below. So on your quiz for this focus, we're going to give you the formulas for these. So I'm going to show you down here on your formula sheet that the volume for a cylinder would be right there. So we need pi r squared h in order to find volume of a cylinder. Okay, so let's go up here and write down our formula. It's going to be important that you show all of your work. So let's write out the formula first. Pi r squared h. R is our radius, so that is the 25 inches. So let's put pi 25 squared, and then your height is 40. And then volume is measured in cubic units. So we're going to end up with cubic inches once we calculate our answer. And then I'm going to write it both in terms of pi and also as a decimal. So if we want to leave it in terms of pi, I'm going to calculate over here on my calculator. I have 20 squared times 40, so just don't type in the pi. And you get 25,000 pi cubic inches. Or if you do want to leave or incorporate the pi, you could do times pi if needed and get that answer. So that would be 78,539, and normally they round to the nearest tenth, so let's put 0.8. Since the problem didn't specify, you could do either one for this one, but just know that on your standardized test they're going to definitely choose one of those two. They would not do both. Number 2 says Leah made 2 candles in the shape of right rectangular prisms. Right rectangular prisms is a fancy word for a box. They love to use that fancy phrase for box. The first candle is 11 centimeters high, 7 meters long, and 5 centimeters wide. The second candle is 3 centimeters higher but has the same length and width as the first candle. How much additional wax is needed to make the taller candle? So we need to find the volume of each one. So her original candle was 11 as its height, 7 as its length, and 5 as its width. So let's do 11 times 7 times 5. And we get 385 cubic centimeters. And that was her original candle, we'll call it. And then the volume of the taller candle is 3 centimeters higher. So it was 11 centimeters high. That's the one thing that's going to change. And so 11 plus 3 would mean it's now 14 centimeters high. And then the length and the width stayed the same. So we'll leave the 7 and the 5. So 14 times 7 times 5 is 490 cubic centimeters. And then how much more wax was needed? We just need to find the difference between the larger one, the taller one, and the original one. So let's do 490 minus 385 would be 105. All right. That should be it for that one. So that much cubic centimeters of wax. If the volume of a sphere is 326 cubic centimeters, what is the radius of the sphere? So again, refer to your formula sheet. Look for the sphere, which is, where did it go? Anyway, it should be 4/3 pi r cubed. I must not have copied the whole formula sheet, but you will have it on yours. So let's carry on. The volume of a sphere is 4/3 pi r cubed. And so they want us to solve for the radius given the volume is 326. So I'm going to put 326 equals 4/3 pi r cubed. A good way to get rid of 4/3 is multiply both sides by the reciprocal, which is 3/4. Because that gets rid of the 4/3 in one nice step. And so I can just type in 326 times 3/4 or 0.75 would also work. And you get 244.5 equals pi r cubed And we just want the radius. So we could divide by pi. So I'm just going to hit divided by pi. And I get 77.83 equals r cubed. And then you have to get the cube root of both sides to get r by itself. So the cube root should be under your math menu. So if you hit the math button on your calculator, cube root should be option number 4. And then you could type 77.83. And you're certainly welcome to carry that out further if you want, but that should be okay. So 4.27 is the radius. And that would be centimeters, so let's add the units right there. So 4.27 centimeters would be a little better way to say that. Okay, so number 4 says find the volume of the composite figure. Now this looks like half of a sphere. We call that a hemisphere. And a cylinder. So we're going to find half of a sphere plus the cylinder volume and add them together. So that volume plus the volume of a cylinder, add those together. So half the volume of a sphere would be half of 4/3 pi r cubed. And then a cylinder would be pi r squared h. So the total volume would be all of that added together. So we have 1/2 4/3 pi r cubed. So the radius in this case needs to be half of the 12 because that's the diameter. So r would equal 6. And then that's going to be the same thing for the radius of the cylinder. So we have pi times 6 squared over here. And then the height of the cylinder was the 13 that they gave you. So let's clean that up. I'm going to calculate just like it looks. And we have 1/2, we have 4/3, we have pi, and we have 6 cubed. So I'm just going to keep it all separated to make sure all of it gets treated properly. They're all just being multiplied together. And let's write that part down. So we have 452.4 plus pi times 6 squared. Again, you can just type it like it looks, and then times 13. And you get 1,470.3. And then if we add that to the 452.4, we get our total. So our total volume is about 1,922.7 cubic inches. All right. So we're finished with that one. And the last problem says the volume in cubic inches of a decorative box can be expressed as the product of the length of its sides. The volume is given as this polynomial and the width is x plus 2, and we need to write the linear expressions for the box length and height. So remember, volume equals length times width times height when we're dealing with a box, and you're given the width. So you got to find the other two. They're going to be in factored form. So think of like, this is x plus 2. These are also going to be some factors we got to figure out. So the best way to go about this is set up for synthetic division. So change the sign of that 2 in your width right there, and you're going to divide the volume by the width. So notice when you take volume equals length times width times height, and you divide by the width, look what happens to your formula. You're left with length times height. So we'll be able to figure out what those are, which is what we're looking for. So -2 is in my box, and then I have my coefficients, which are 1, 6, 3, and -10 from my polynomial for volume. Bring down the first number to get started. So we bring down the 1. 1 times -2 is -2. We add the 6 plus the -2, and we get 4. 4 times -2 is -8. 3 plus -8 is -5, and -5 plus -2 gives me 10, and so I have no remainder, which I should have because I knew that should divide evenly. And then my remaining polynomial would be x squared plus 4x minus 5. But we got to break it up into a length and a height. like we wrote over here. So that would be what would multiply to give me -5, and what will add up to give me +4. So -1 times 5 or -5 times 1 are my only options of what will multiply to be -5. And that first pair of numbers would add up to be +4. So then my length and my height, it doesn't really matter which one's which, would be x minus 1 and x plus 5. So those are your dimensions of what was left, which was the length and the height. And don't label one or the other because we don't have enough information to determine that. Okay, so that is it for practice quiz 14.